أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Dear students, today we are going to do the lecture Chemistry Involved in the Processing of Semi-Chemical Pulp. The main concepts which shall be discussed in this lecture will be the definition of semi-chemical pulping, cellulose, lignocellulose, lignin, purpose of pulping, why to remove lignin, and semi-chemical pulping intro. And the next about the semi-chemical pulping will be discussed in the next lecture. Semi-chemical pulping. What is semi-chemical pulping? It is basically a method. It is basically a procedure. It is a technique of pulping, method of pulping. There are different type of pulping. So the semi-chemical pulping is actually a method in which wood chips are converted to the paper pulp. We convert wood chips into the paper pulp using semi-chemical pulping and many or different procedures of pulping. So, for what purpose this pulping is done? The pulping is done for making a pulp from wood chips or some other materials. Why the pulp is made? The paper pulp is made for making up paper. And for using this semi-chemical pulping method, a combination of chemical and mechanical procedures or techniques or methods are utilized. So on the whole we can say that semi-chemical pulping is a method in which we convert the wood chips into the paper pulp, and we make the paper pulp for paper making. And for semi-chemical pulping we utilize chemical means also and mechanical means also. Combination of both chemical and mechanical means. The wood pulp. What is the wood pulp? You have studied it before also. Wood pulp is basically lignocellulosic fibrous materials. Or from where is that produced? It is produced from the wood or from some other materials which we have discussed in the previous lecture. So from the wood, if we separate the cellulosic fibers which are present in the wood, which separate these cellulosic fibers from the lignin. So these two things are present in the wood pulp. It is a lignocellulosic fibrous material, and from the wood these two cellulosic fibers are separated from the lignin by mechanical means or chemical means, like using chemicals or by using other mechanical means. We separate cellulosic fibers from the lignin which are present in the wood. So when this is done, the pulp is made in which some percentage of lignin and some percentage of cellulose fibers is present.
What is cellulose? Cellulose is an organic compound with the formula C6H10O5N and is showing that this is a repeating unit, and n number of these repeating units have been found in the structure of cellulose. Cellulose is a polysaccharide. Polysaccharide is a carbohydrate basically that is made up of sugar monomers. So Cellulose is a polysaccharide that is consisting of a linear chain of several hundred to many thousands of 1,4 linked beta 1,4 linked D-glucose units. When 100 to thousands D-glucose are linked together by 1,4 beta linkage, making up a linear chain, the polysaccharide is made, and that polysaccharide, which is made by the 1 to 4 beta 1 to 4 linked D-glucose units, is called cellulose. Cellulose is an important structural component of primary cell wall of green plants. So that is the constituent of cell wall, and that is the important structural component of the primary cell wall of green plants. Specifically for the green plants, it is told the cellulose is the component of cell wall. Plant's cell wall. The term lignocellulose refers to the plant dry matter, the biomass, the plant dry matter. So it is called lignocellulosic biomass also. It is the most abundantly available raw material on the earth. Lignocellulose, and this is the most abundantly available raw material on the earth for the production of biofuels, mainly bioethanol. Lignocellulose is the most abundantly available raw material on the earth for producing biofuels. Lignocellulose is made up of carbohydrate polymers, cellulose and hemicellulose, and an aromatic polymer, lignin. Now, what is lignin? We are going to discuss it on the next slide. Lignin is a class of complex organic polymers that form key structural materials in the spore tissues of vascular plants and some algae. So it is a class of complex organic polymers. They are polymers, but they are complex organic polymers, and they are making key structural material in the spore tissues of vascular plants and some algae. Lignins are particularly important in the formation of cell walls, especially in wood and bark, because they lend rigidity, they contribute rigidity, and they do not rot easily. So these lignins are important in the formation of cell wall. Wood and bark especially, because of their contribution to the rigidity and because their capability of not being destroyed easily. They do not rot easily. So the pulp is a lignocellulose. This lignin and cellulose both are making up pulp.
Purpose of pulping. What is the purpose of pulping? The purpose of pulping is basically to separate individual fibers of cellulose from other non-fibrous components of wood, in particular lignin. What is lignin? We have studied it before, that Wood pulp is cellulose, combination of cellulose and lignin. Lignocellulose wood pulp is basically a lignocellulose. So in which we have discussed the structure of cellulose, and now if you check the lignin, it is an organic material that basically binds the cellulose fibers together. And if we use cellulose and lignin, cellulose along with the lignin as such, as they are present in the wood, it will be a detriment to paper making. Detriment is something which is harmful. So we are saying that the purpose of pulping is to separate the cellulose fibers from non-fibrous components of the wood, which is mainly lignin. And lignin is an organic material. It is binding the cellulose fibers, and if it is not removed or it is not separated, then it is a detriment to the paper making. How is it detriment? We are going to see it in the next slide. Why to remove lignin? As we noted, lignin is a natural glue. It holds the cellulose fibers together, and it gives the plant stems, it gives stiffness to the plant stems. So it stiffens the plant stems, but it is useful for the plants, for the wood, but it is harmful for paper, because the paper, which is made up of wood pulp, if there is too much lignin present, it will be weakened and will be discolored rapidly. If the lignin is not removed in the paper mill, the paper which is produced will be weakened and discolored. It will be discolored rapidly. So lignin is itself harmful if it is not removed in the paper mill from the cellulose fibers. The other two types of pulping, mechanical pulping and chemical pulping. The other two types of pulping, if are used, if these pulping techniques are adopted, so what will happen? Actually, wholly mechanical pulping, fully mechanical, it generates a high pulp yield. The pulp which will be yielded from mechanical pulping, it will be in greater amounts. Yield will be higher and costs comparatively little. If all of that is mechanical pulping, the cost will be lesser, but it removes little lignin. So we can say that if we are using mechanical pulping, completely mechanical pulping, it is generating the pulp, the high yields of pulp. It is generating comparatively commercially cheaper pulp, but little lignin is removed in the mechanical pulping. While if whole of that full chemical pulping is used, then it removes the most lignin, but is expensive and has low pulp yields. So if we compare both pulping techniques, fully mechanical or mechanical pulping, as in comparison with the chemical pulping, so we can see the chemical pulping removes most amount of the lignin, but in the other aspect it is expansive, and the yield of pulp is also low. So if we consider the yield, so mechanical pulping will give high yield and chemical pulping will give low yield. If we will consider the cost, mechanical pulping will be commercially cheap, chemical pulping will be expensive. But if we consider the amount of lignin which is removed, in the mechanical pulping little lignin is removed. In the case of chemical pulping, most of the lignin is removed. So the choice will be ours, which type of pulping shall we use. Semi-chemical pulping. Briefly, if we see what happens in the semi-chemical pulping, the wood chips are first softened by chemically treating them in a neutral sodium sulfide solution. So the first one thing which is done is the treatment of wood chips with neutral sodium sulfide solution. By treatment with neutral sodium sulfide solution, the wood chips are softened. They become softened. Then after softening, they are for other processes they are used. Now, wood chips are first subjected to mild cooking, and most commonly sodium sulfide, which is combined with a small quantity of alkaline salts such as sodium carbonate, sodium bicarbonate, or sodium hydroxide. These are all alkaline salts. Small quantities of these alkaline salts are used along with the sodium sulfide. So now the wood chips are cooked mildly along with sodium sulfide, and which contains a small amount of these alkaline salts. So all this is done to make the wood chips soften. After treatment with the sodium sulfide combined with alkaline salts solutions, these mildly cooked wood chips are subjected to mechanical pulping with the help of devices such as disc attrition mill. Why they are subjected to mechanical pulping? They are subjected to mechanical pulping action for the separation of fibers. Now, what is attrition mill? Attrition mill is basically a machine in which materials such as any grains or spices, they are pulverized between two tooth metal discs rotating in opposite directions. So means the material, the grains or spices are ground. They are converted into the powder. And how this is done, the pulverization is done between the metal discs which are having teeth, and they are rotating in opposite directions, and they are just crushing the for example grains or spices or anything which is placed in between them. This is the work of attrition mill. So first we have said that we have make them with the wood chips softened using sodium sulfide along with alkaline salt solutions. Then we have subjected them to the mechanical pulping action using disc attrition mill. And we have used disc attrition mill for the separation of fibers, and an attrition mill is a machine in which materials are pulverized. These machines are having tooths, like they are having metal discs which are rotating in opposite direction, and these metal discs which are rotating in opposite directions are having teeth on their edges or margins. Such wood pulp produces high quality paper with varied characteristics. These which are made up from the semi-chemical process. They are used to make up for high quality paper, and the characteristics of that high quality paper are varied. Varied means they are of various, like the characteristics can be of various types. Different type of characteristics can be found as required, or they can be produced in the paper of which is made from this wood pulp. So we can say that after cooking, the chips are sandwiched in a disc refiner. As we have stated about the attrition mill, similarly, they are after cooking, they are sandwiched in those disc refiners. What are those disc refiners? They are two rotating serrated. We have explained. I have explained that the discs which are having tooth at the margins or edges. So these rotating serrated discs. Serrated is the same saw, like or notched, or having teeth at the margins or at the edges. So these rotating serrated discs, they separate the individual fibers of cellulose. We have said that in the previous slide. We have said that attrition mills, we use attrition mills for separating the individual fibers of cellulose. After cooking the chips, we just put them into these serrated discs, rotating serrated discs. This is called disc refiner or attrition mill. The pulp is then washed to remove the chemicals. As we have treated the pulp with the chemicals, so at the end, when the pulp is like after doing chemical treatment and then mechanical treatment, after doing both of these treatments, the pulp is washed, and this is washed to remove the chemicals which we have used. Besides other advantages, one of the advantages of the chemical pulping is the higher lignin removal. And as we have studied before, the advantage of mechanical pulping is high pulp yields. So we have said that mechanical pulping is commercially is cheaper. It costs less, and as compared to the chemical pulping. Chemical pulping, the removal of lignin is higher, but the yield is low. And mechanical pulping, the yield is high, and it is commercially cheap also. The semi-chemical wood pulping method yields more as compared to the wholly chemical wood pulping method. So if we compare all these three, chemical pulping, mechanical pulping, semi-chemical pulping, so we would see that the yields are higher in mechanical pulping, but and it is also commercially it is commercially cheap, but it contains high amount of lignin. While the chemical pulping is having high lignin removal, like it after the process of the chemical pulping process, the high amount of lignin is removed. The yields are low also in chemical pulping, but in the case of semi-chemical wood pulping, the yields are higher than wholly chemical wood pulping. So the drop of yields is not that much as is in chemical pulping. So in the semi-chemical pulping, the yield is higher than wholly chemical wood pulping method. The yields in the pulp yield in the semi-chemical process is generally from 60 to 80% of the original wood, but much of the residual lignin still remains in it. So there is approximately 50% lignin retention, and there is 30 to 40% hemicellulose. So if we see what is hemicellulose, then we shall again see the percentages of different chemicals present in the pulp which is produced by semi-chemical pulping process. Hemicellulose is actually is a class of substances which occur as constituents of the cell walls of the plants. They are present in the cell walls of the plants. They are polysaccharides, and they are more simpler polysaccharides as compared to cellulose. So they are called hemicellulose, and their structure is more simpler as compared to the cellulose, and they are polysaccharides which are found in the plant cell walls. Now we see that the pulp yields in the semi-chemical processes are from 60 to 80% of the original wood. The original wood we have used, about 60 to 80% will be the yield of the pulp produced from the original wood. And lignin is much of the residual lignin is still there in the pulp which is produced by semi-chemical pulping process. 50% lignin retention is there, and there is 30 to 40% hemicellulose also present. Now both these factors make the semi-chemical wood pulping more commercially attractive than chemical wood pulping. The percentage of the pulp and the presence of there is a retention of 50% lignin retention is there, and the hemicellulose, the percentage of the chemicals and the percentage of the pulp yield, both these factors make the semi-chemical wood pulping more attractive as compared to the wholly chemical wood pulping. The semi-chemical wood pulp finds its utility in important manufacturing processes, such as in the manufacturing of high-quality corrugated paper. Corrugated paper is what you can see on the next page, in the next slide. So semi-chemical pulping results in stiff fibers, and the process is used to make corrugated paperboard, cardboard, roll cores and containers. So due to its stiffness, it is used to make high quality corrugated paper. Now, what is the corrugated paper? Corrugated paper is actually the paper which is quite stiff and having layers of the sheets which are just placed in a manner to make the paper more stiff and strong, you can say that. You can see the example of corrugated paper on the next page, on the next slide.